Alright, this is the 9.4 part 1 video. So in this, we're going to be solving quadratic equations, so equations with x squareds. And the reason why I have this absolute value written over here is because it turns out these are very similar. So I'm just going to do a quick review of absolute value functions before I jump into actually how to solve quadratics. So when we're trying to solve absolute value functions, if you remember, we split to two equations. The second we're trying to undo our absolute value, we split to x equals 9 and x equals negative 9. So two different answers make this true. And that's because the absolute value of negative 9 is 9, and the absolute value of 9 is 9. So it works both ways. This is going to be very similar to quadratics when we start solving them. When I go and square root both sides of this equation, one of my answers is going to be x equals the square root of 9, which is 3. And my other answer is going to be x equals the negative square root of 9, which is negative 3. And this is because 3 squared is 9, and negative 3 in parentheses squared is 9. Negative 3 times negative 3. And that's because the negatives cancel. And we just get back to a positive 9. And so these are the easy types of questions. So to look at another example of this type of question, x squared equals 81. If I want to solve this equation, I'm going to square root both sides. I'm going to split to two equations. In one of the equations, x equals the positive square root of 81, which is 9. And one of them, x equals the negative square root of 81, which is negative 9. Now, there are some curveballs that can be thrown in here. If I get an equation like x squared equals negative 7, and I'm trying to solve this, well, there's this special property of squareds that's very similar to absolute values. If you remember our absolute value equivalent of this, absolute value of x equals negative 7, we said you can't make a number positive and then have it equal to a negative. Well, it's the same with squareds. If I square a number, it's always positive, which means it can't be negative, which means this is an impossible question. So we just say no answer. Or you can do a thing like this, or any of those sort of things. On Pearson, you'll just select the no answer choice from the list. It'll say either there's an answer and x equals blah, or there's no answer. So now I want to talk about the kind of trickier questions on this homework. So they're more like questions like x squared equals 12. And the reason this is trickier is because we don't know like the square root of 12. It's not a whole number. It's some decimally thing. So here's the way they expect you to do it on the homework. Same as before, we square root both sides. We get two answers. X equals the square root of 12, and x equals the negative square root of 12. Now, Pearson doesn't accept two answers, so what you have to do is go a little further. You're going to have to actually solve this out the way we were doing last week, so simplifying under a radical. And what multiplies to give 12 but 4 and 3? And the square root of 4 is 2, so this is 2 root 3. And that makes this one also 2 root 3. So one of my answers is x equals 2 root 3, and one of them is x equals negative 2 root 3. To give a couple more hints as to how these should go into Pearson is they're going to have like an x equals line. And then you're going to write in 2 root 3, comma, negative 2 root 3, like this into Pearson, and they'll accept that answer for if you have x squared equals 12 as a problem. So to do another kind here where the numbers are a little less kind, let's try x squared equals 50. All right, in this question, we square root both sides. Boink, boink. Split to 2. X equals root 50. X equals negative root 50. And now I have to simplify into the radical. So what goes into 50? 2 and 25. And the nice part is, I know the square root of 25. It's 5. which makes this answer just 5 root 2. Just in case you don't follow this line, I do these two different ways. I want to show the other way. So I got 5 root 2 this way by just splitting this to root 25 times root 2, and knowing that the square root of 25 is 5. But the other way of doing these, just as a little reminder, is to take 50 and say, hey, 2 and 25 go in, and then in 25, 5 and 5 go in. Circle a pair, that gets to come to the outside, that's this 5. And the 2 is stuck on the inside and stays inside the root. And our other answer will be negative 5 root 2. And those would be our two answers in simplified form. And in Pearson, we'd enter them like this. X equals 5 root 2, comma, negative 5 root 2. And that's that stuff. I'm just going to peruse real quick, make sure I covered everything. There are 7 questions on this homework, but some of them are very fast. You may have noticed these are not long questions. Okay, there is one curveball I should go over as a additional question. Not every question is just this simple, like x squared equals 16. It doesn't always look like this. Sometimes there's more stuff on either side, and that's kind of the direction we're going to be going with our next homework, when our second day on 9.4, is we're going to have stuff like 3 minus x squared equals 16. And in this one, the two x values are not going to be just positive and negative of the same number. So very similar to when we solved absolute value equations, whenever there's a parentheses, things get like different. You can't just say x equals positive and x equals negative. But again, that's something we're going to mess with next time. The kind of messing with that we're going to do this time is something like this. What if you have 3x squared equals 8, and you solve this? Well, our first step here is not to square root like all of our other questions. Our first step is actually to get that 3 to the other side, because we need the x squared by itself before we can square root both sides. So you get 8/3 equals x squared when you divide by 3 on both sides. And 8/3 is like some decimal, but I'm just going to leave it as 8/3 for now. Okay, so when we square root both sides, we get x equals the square root of 8/3, and x equals the negative square root of 8/3. And then we run into a little conundrum that makes us think back to our exponential rules earlier this year. If you have to simplify the square root of 8/3, there is actually a way to simplify this, which maybe is not obvious from the get-go. First idea, x equals... okay, so the square root of 8/3 is the same as the square root of 8 over the square root of 3. That's the really key first piece. So when you have division inside a square root, you're allowed to square root each of the things individually and then divide them, which is how we're going to get places here. The square root of 8 actually does factor, because 8, if I prime factorize it, it goes to 4 and 2, and then to 2 and 2. We can circle a pair and take a pair out, which means this is 2 root 2, this root 2 is stuck inside, over the square root of 3 as our remaining piece. And we get negative 2 root 2 over the square root of 3. And there's actually even farther you'd go in like Algebra 2, but in here, we don't need to go any farther right now. This would be okay. We'd have simplified all the insides. You could even write this final answer. And weirdly, this final answer that I wrote here, this janky thing, is the exact same as, let me wipe out this question that we're not going to do yet. It's actually the same thing. So 2 root 2 over root 3 is the same thing as 2 times the square root of 2/3. So just a reminder that numbers that look different can have the same value, and this is like a really weird case where things can look different but be the same. The key idea being that fractions are just division, and you can split it up to be division to simplify your question, or not to not do that. Now, the question on your homework, I guarantee, is easier than this one because I took a peek at it. So you won't have to do as much gymnastics here. You'll probably be able to chill at this point, which is pretty nice. But I wanted to go a little further just to point out some of the weirdness of square roots and kind of where we're going to be going next class. You shouldn't have too much of a problem with this homework, but if you run into any difficulties and it's Tuesday, then you can just come to my stream on Wednesday and ask me any questions, and I'll be happy to answer them live. So I am streaming on my YouTube channel, which is where this is. So if you found this, it's the same place. At 2 p.m. on Wednesday. So let me write that 2 p.m. to as late as 3 p.m., but we probably won't go all the way till that. It kind of depends on interest on Wednesday. So I will be just, we'll start with a warm up for maybe like a 10-15 minute warm up, and it's going to be all stuff from Chapter 9. If you showed up to any during the early part of the quarantine, it's going to be structured pretty similarly to that. We're going to do this warm up at the beginning, and then I'm just going to have people ask me questions about that they struggled with on the homework. I can do examples. I can go into Desmos, whatever helps. So please take advantage of that if that's something that would be helpful to you. If you missed it, if you watch this video a little later, I will be doing this again next week. So 2 to 3 p.m. on Wednesday is my Algebra 1 help time to help people with homework if they're struggling with anything. And that's it. I will talk to you again maybe on Wednesday or definitely on Friday. Adios.